lecture on some changes that happen to the human body in terms of body composition and metabolism as we age from October 16th, 2020. Right, and so in this lecture, we're going to talk about energy balance, as well as what energy expenditure is and how to calculate it, and how age plays a role in energy expenditure and how this affects body composition, as well as the mechanisms that are associated with the weight decline that we see in aging humans. And so there's no doubt that body composition differs as we age. And what I'm really talking about when I'm talking about body composition is the amount of water, bone, proteins, and fats, or lipids, that make up your body. And ultimately, the amount of water in your body stays relatively the same throughout your life, over aging as well. And so it's these different components, bone, protein, and lipid, that do change as we progress from birth to death. So from birth to puberty, the rate of protein deposition is actually favored. And you can imagine that that's in order to really grow and develop, right? We have to build organs, we have to grow in size, build muscles. And so the amount of protein goes up quite a lot between infancy and the beginning of sexual reproduction, or puberty. And the rate of protein deposition tends to be relatively similar between males and females. And then at puberty, that changes. And both sexes will experience increases in the amount of bone that they have. So both males and females will get more bone mass after puberty. But in males, muscle development and the continuation of this protein deposition is favored after the start of reproduction, whereas in females, fat deposition increases. It's like, in every female listening right now is like, of course it does. So there are some differences in sort of which part of your body's composition is favored after reproduction begins at puberty. And during development, which is really the period from infancy all the way up until about age 25, the body's composition and how much fat versus protein versus bone versus water we have is strongly influenced by genetics, and it's actually relatively predictable. However, after age 25, or between 20 and 30, after development is over and we start to enter into maturity, our body composition becomes more heavily influenced by our own choices, i.e. the environment, right? And so what does remain constant through maturity and then ultimately into senescence is the amount of water, bone, and muscle that you have during this maturity phase. So water doesn't change, bone doesn't change, muscle might decrease a little bit through maturity, but it stays relatively the same until senescence. And that means the only thing that can really change in your body composition is the amount of lipid or fats. And so fat stores are dynamic throughout maturity. And then after maturity in senescence, all components of the body composition, bone, muscle, fat, and water, all decline. And so in order to kind of affect body composition, we have to take into account this idea of energy balance. And energy balance is basically just equal to the amount of energy we intake through food minus the amount of energy we expend or give off, right? So we need energy to live. We get our energy as humans through the food that we eat. And you can see some calorie contents or energy contents in kilojoules per gram for the different macronutrients in this table here. And so energy intake is relatively easy to calculate, right? You can figure out what you eat and how much energy is in it, and that is your energy intake for a particular day. Energy expenditure can be a little bit more difficult to calculate. It takes into account 3 different things, right? So the total energy you expend, or the TEE, takes into account your resting energy expenditure, or the energy you use during periods of rest, just to sort of maintain your posture, your stability, and all of your normal bodily functions. And that actually constitutes about 70% of your total energy expenditure for the day, is just that resting energy that you expend. Then you have energy that's used for digestion and absorption, or diet-induced thermogenesis, right? That's about 10% of the energy we use every day. And then total energy also takes into account the energy you use during physical activity. So any movement of your skeletal muscles requires energy, therefore expends energy. And this is really the variable thing in total energy expenditure, because there's not a lot of variation in how much resting energy your body uses, and there's not a lot of variation in how much energy is used by diet-induced thermogenesis. So really the only thing that you can modify in this situation is physical activity and the energy you expend doing that, which is anywhere from 20 to 30% of the energy you expend. And so I want you to take a second and calculate or work through this problem, right? So if a person takes in 9,267 kilojoules of energy per day, and they constantly expend this much in their resting state, and 881 through diet-induced thermogenesis, how many kilojoules do they need to expend through physical activity if they want to remain in that state of kind of energy balance, where intake equals expenditure? So take a second, pause the video, and work through this problem. Okay, so if you want to remain in energy balance, your total energy expenditure needs to equal your energy intake for that day. So that means total energy expenditure needs to equal 9,267 kilojoules, because that's how much this person is taking in energy. Their resting energy is 6,150, and their diet-induced thermogenesis is 881. And so you can take the total energy expenditure, which is a sum of the resting energy expenditure plus physical activity plus diet-induced thermogenesis, and then calculate the amount of energy that would need to be burned via physical activity by basically taking the total energy expenditure minus the resting minus diet-induced thermogenesis, and get about 2,236 kilojoules of energy for this person to stay in energy balance and not either accumulate more fat or lose fat. And you can imagine that that actually ends up being relatively easy to accumulate and lose fat throughout your life. It would only take a small increase in the amount of either calories and energy taken in via food, or a small change in the amount of physical activity and the energy expended there over long periods of time, over your whole life. And it can actually lead to relatively large changes in body composition. Right, and so some of the things that happen with age that can lead to changes in body composition as well are the changes in food intake, right? And so we already just talked about how food intake and physical activity are the two things that have the largest impact on energy balance and on body composition. And so based on these graphs here, you can see that calorie consumption as a whole decreases in older individuals as compared to younger individuals. And this is true for both males and females. And what you'll notice is that while that trend is true for both males and females in this top graph, we're actually consuming a lot more calories now just as a people in 2000 than we were in 1970. And so even though calorie consumption still decreases as individuals age, they're actually consuming a lot more calories, and so obesity and being overweight is becoming sort of a new problem for older individuals. And that's partly because it becomes more difficult to change your physical activity, right, with age. And so we know that physical activity decreases in older individuals compared to younger individuals, right? And so this is a graph showing the percentage of adults who actually met their physical activity guidelines in 2008. It's a little bit sad because it only ever reaches about 35% of the population. So people are not in general meeting their goals. But when you compare these older individuals, old 75 and over, to younger ones, physical activity declines with age. And so this combination of increasing the kind of amount of calories you should be intaking and decreased physical activity can lead to being overweight, but overall, weight seems to decline with age. And when we think about body composition, we don't necessarily always just think of weight. Kind of a better way to measure body composition is a measurement called BMI, which is the ratio of weight to height. You can see the equation for that here. And BMI and mortality are actually highly correlated. And so there is sort of there's multiple categories for where your BMI should be. There's an underweight category of a low BMI. There's sort of a healthy weight range, and then there's an overweight and obese range above 25, right? And so what you can notice is that once we reach 25, for both males and females, the relative risk of death or the increased mortality or the mortality rate increases. So higher BMI is correlated with higher risk of death. Or is it? Right, and so this is kind of a general population measure on the top graph. This graph is a measure of kind of the risk of death or mortality versus BMI for people who are specifically over the age of 65. And what you'll notice here is that there's a high risk of death or mortality at low BMIs, and there's a higher risk at very high or obese kind of levels of BMI. Here at 25 to 29, which is normally considered overweight in the general population, is actually the lowest risk of death. And it seems like those healthy weights between 18 to 24 actually have a higher risk of death than individuals who have a little bit more or have a little bit higher BMI. And so it's important to remember that while BMI and mortality are correlated, and higher BMI in younger individuals means higher risk of death, in older individuals, it's actually equivalently dangerous to have a low BMI as it is to have a very high one. And that's why usually individuals or adults who have kind of this overweight BMI and are over the age of 65, their doctors won't recommend weight loss regimens for them because it's actually better for them to have a little bit more weight because it lowers their risk of death. And so there is an excessive occurrence of weight loss near the end of lifespan. And I'm sure you've seen anecdotal evidence of this in either family members or friends who you know who have been aging. And the excessive weight loss really just is a decline in the amount of body fat and the amount of muscle. But the underlying mechanisms for excessive weight loss that happens very close to the end of lifespan is relatively unclear still. But it results in this clinical condition called anorexia of aging, right? And this condition is basically a loss of appetite that ends up leading to this excessive weight loss. And there are some things that might affect appetite and that actually might contribute to anorexia of aging that I'm going to talk about here. So one is that food becomes less tasty and smells, your sense of taste and smell go down, so it smells less tasty as well, which means you just overall consume less food because it's not really as satisfying to you. It doesn't taste as good, doesn't smell as good, and so that decreases energy intake. Additionally, there are changes in specific hormones, one called leptin, which is secreted by your fat cells, and another one called ghrelin, which is secreted by your stomach. And normally, ghrelin is secreted at high levels to indicate hunger. And then you eat, and once you eat and you're satisfied, ghrelin goes down, and leptin in your adipose tissue goes up to say, I'm satisfied. And in older individuals, ghrelin stays at a low level, so they never feel hungry. And leptin stays at a high level, so they always feel satisfied, which means they're not intaking a lot of food because they're not hungry. And there's a lot of question marks as to how this works in the brain, but the levels of hormones in older individuals is something that's been confirmed. So it's basically a combination of being less hungry and feeling more satisfied, as well as food just being less satisfying in general, that can lead to this decreased energy intake. And anorexia of aging is one part of this larger syndrome called geriatric failure to thrive, which you can see here has other components like cognitive impairments and depression.